In this video, we're going to begin solving equations using inverse operations. And the problems in this video are going to involve the basic four operations of adding, subtracting, multiplying, and dividing. One really important point when you're solving equations is that as you simplify, you can't just throw operators away. Instead, there has to be a reason that the operators are no longer there. And for the basic four, we've got a couple of reasons. The first is the additive identity. Zero, the number 0, is the additive identity. And if you have a sum of 0 and another term, you can replace that with the other term. There's another property, the multiplicative identity, which is the number 1. And the product of one and another factor can be replaced by the other factor. So you'll see here on the left that I do have an operator, and on the right I don't. That is, in a sense, I've lost an operator. But the reason it's working is that I'm allowed to replace this expression by this expression. And the same for the multiplicative identity. I can replace this expression with this expression. So here's an example of what I'm talking about. Right now, I'm trying to figure out what value y should be so that both sides are 4. Now, the reason I can't see immediately what value I should choose for y to make this side 4 is that I'm adding 10. That is, I have a sum over here. So in order to get rid of this operation of adding 10, I'm going to use an inverse operator and subtract 10 from the left. Of course, by the property of equality, I've got to subtract 10 from the right also. Now, the reason subtracting 10 from the left works so well is that when I collect like terms and get y plus 0, as we just saw, I'm allowed to replace that simply with y. And looking at this equation, it's very easy to see that I should choose the value -6 for y. Again, if you want to be technically correct, you can make a solution set. Most people stop here, and that's fine. Now to check our work, we go back to the original. Again, the left side was supposed to become 4. We substitute our guess here that maybe -6 will make that happen. And then when we add, we do get 4 on the left. And so since we have 4 on the left and the right, we know that this is a very good, we know that our answer is the solution. Try this one. In this case, the reason it might be difficult to see what value p should be is because we've got this operation of subtraction. To undo that, I'm going to add 9 to both expressions. On the left, I'll get -2. On the right, I'll get p plus 0. And again, I can replace p plus 0 with simply p. And it's easy to see that I should choose -2 for my variable. And I can run a check just to make sure. And it turns out, since both sides do become -11, that this is a good choice. Now here's the first one that involves the multiplicative identity. See if you can figure it out. What makes it difficult to see what value x should be is that I'm dividing by 17. To undo that division, I'm going to multiply by 17. So on the left, I'll multiply by 17, and on the right. On the left, I can reduce my factors of 17 to a factor of 1. And on the right, 3 times 17 simplifies to 51. Now again, here's the important idea. If I have a product with a factor of 1, I can just replace it with the other factor. And then we should always check our work. Here's another. In this case, the issue is this factor of -15. The inverse would be to divide by -15. I've got to divide by -15 on both sides, though. That's what that property of equality told us. Over here on the right, 2 negatives are going to give me a positive, and it's going to be a +1. And on the left, if I simplify, I'll just get negative 7. And again, I can replace 1 times x simply with x, and it's easy to see I should choose negative 7 as my answer. To see if it's really the solution, I go back to the original. I substitute and simplify. I get the same value. So my solution is negative 7. How about here? This time I'm dividing by negative 7. The inverse would be to multiply by negative 7. I do that to both expressions. On the left, I can reduce the factors of negative 7 to a factor of positive 1. On the right, I multiply and I get negative 91. And then again, I can replace 1 times x simply with x and see that my answer is negative 91. I check my answer, and sure enough, I get the same value. So that's my solution. How about here? To undo this addition of 23, I'm going to subtract 23 from both expressions. On the left, I'll get negative 45. On the right, I'll get x plus 0, and that gets to be replaced by x. Last, I'm going to check my work. Now again, in practice, I'm going to stop doing this because people don't. They just go right from here to here. But in this video, I just want to keep making the point of why this operator isn't there any longer. Here's our last one. The issue here is that factor in negative 8. So let's divide both expressions by negative 8. On the left, the quotient is going to be a positive 1. Negative 8 divided by negative 8 will be a positive 1. And over on the right, when we divide, we get a negative 17. I can replace 1 times y with y and see that my answer is negative 17. And then I check and see that I do get the same value. And so this is my solution. Well, that will conclude this video where we've begun solving equations that involve the basic 4.